This video is on exercise 1B questions 5 and 6 of A-Level Further Maths Core 1 textbook. This exercise is all about solving equations that have complex roots or the discriminant is 0. And question 5 is asking us to solve the equation z squared minus 8z plus 21 is equal to 0. So let's write the quadratic formula, and that's minus b plus or minus the square root of b squared minus 4ac divided by 2a. So here we have 8 plus or minus square root of minus 8 squared is 64. And we have minus 4 times, so a is 1, c is 21. So minus 4 times 21 divided by 2. And we get 8 plus or minus, so minus 4 times 21 is minus 84. 64 minus 84 is minus 20 divided by 2. And let's write root minus 20 as 8 plus or minus I root 20 divided by 2. But we are not done yet, because it's better to write 20 as the square root of, it's better to write 20 as 4 times 5, because 4 is a square number. And we can take the square root of 4, and then, we will get just a more simplified answer. So that's better. In this case, 8 plus or minus, so let's write that, I root 4 times 5 divided by 2. And now we can write this 8 plus or minus 2i root 5, because the square root of 4 is 2, divided by 2. Now let's divide each of these by 2. So 8 divided by 2 is 4, plus or minus 2i root 5 divided by 2 is I root 5. And that's it. So the answer is in the form a plus or minus I root b. Question 6. This is an interesting one. The equation z squared plus bz plus 11 is 0, where b is a real number and has distinct non-real complex roots. Find the range of possible values of b. So what does this mean? So because it says that b has distinct non-real complex roots. Since this is a quadratic equation and it can have two roots, when it says has distinct non-real complex root, it is simply stating that it has two complex roots which are different. And now we should find a range of possible values of b. So it's not asking us about the solutions or the roots of this equation, because b is unknown and we cannot really do that, but we should find the range of possible values of b. And how can we do that? We should use this fact, because this fact allows us to work out the range of possible values of b. Since the question is saying that this equation has distinct non-real complex roots, the first thing that should come to your mind is that when an equation has complex roots, the discriminant must be 0. And we are going to use that in order to solve this question, because when the discriminant is 0, when the discriminant is less than 0, we will have two complex roots. Now in this question, since this has complex roots, so the discriminant must be 0. Now let's work out the discriminant. So the value of b here is also b, so b squared minus 4, so a is just 1, and c times 11, so c is 11, so we write minus 4 times 1 times 11 is less than 0. And we have b squared minus 44 is less than 0. And we simply have to solve this inequality, and we can find the range of possible values of b. And that's why they are asking for a range of values of b, because we have an inequality. We don't have an equation to to just find the possible values of b. We can find the range of possible values of b. And you can, use graph, just draw a sketch for b squared minus 44, and here is minus 40. Let's say here is minus 44, so you will get something like this. And obviously the roots of this equation, if you just say let b squared minus 44 be equal to 0, then we have b squared is equal to 44, and b is equal to plus or minus root 44, which can be written as plus or minus 4 root 11, because 44 can be written as 4 times 11, 2 root 11. So root 44 can be written as 4 times 11, and the square root of 4 is 2, so 2 comes out. And that means that here is positive 2 root 11, and here is negative 2 root 11. And don't forget that we want to solve this inequality, and these are the steps of solving that. And so we want to know when the left hand side is less than 0, or just simply the curve is below the x-axis. And in this case, obviously in this case here should be the b-axis, but so in this area the graph is below the x-axis, and that means that when the value of b is between minus 2 root 11 and positive 2 root 11. So when the value of b is between of these two numbers, then that's where we have complex roots, because in this case, when the value of b is between minus 2 root 11 and positive 2 root 11, that's when we are going to get a negative discriminant, and as a result of a negative discriminant, we are going to get complex roots. So I hope this helps, and thank you for watching. Make sure to subscribe for more videos. Good luck.